So hello and welcome back. So in this video we have another good example from the Khan Academy, and the question is the amount of carbon dioxide CO2 in the atmosphere increases rapidly as we continue to rely on fossil fuels. The relationship between the elapsed time t in decades, so t is in decades, since CO2 levels were first measured and the total since CO2 levels were first measured and the total amount of CO2 in the atmosphere, A of decade of t, so this is the total amount of CO2 in the atmosphere, which is basically this function, in parts per million. So the output of this function is in parts per million, is modeled by the following function. So A of decade of t is equal to 315 times 1.06 raised to the tth power. Now the question that we want to answer here is every year the amount of CO2 in the atmosphere increases by a factor of what? And so basically here I don't know what's happening every year, because this function takes inputs based on decades. For example, 1 decade, 2 decades, 3 decades, and so on and so forth. It just gives me a vast array of information in just one plot, for example, related to 10 decades. So let's say on my current PC screen, I can, if I did the plot of this function, I could fit in basically 10 or 20 decades of that function. I could see everything in one single shot, in one plot. But then if I could basically zoom in on that function, then I would basically have to keep stretching that function and keep stretching and going to see basically the years and the months and the weeks and the days, and so this way you could just keep zooming in and zooming in. But as you zoom in, the function has to be stretched horizontally, and then the whole, for example, 10 decades could not fit on one screen anymore. So that's basically what happens in any function. Now this function takes inputs in units, in decade units, and then it gives me some sort of output corresponding to that input. Now I want to know what's happening every year. So based on this, I need to create another function. So basically my function is A of decade of t. So t here as an input must be input as in decades, is equal to 315 times 1.06 raised to the power t. Okay, so let's call this equation number 1. And if I want to, based on this function, if I were to create another function that would take in t as years, I would simply write A of year of t, and then of course I wouldn't have to worry about these numbers. These are just numbers. These are not, basically they have nothing to do with the variable. So 315 times 1.06 raised to the power. So basically if I enter a 1 here, for example, let's say a number 1, that would mean basically 1 year. So 1 year would be basically 1/10 of a decade, because every decade is basically 10 years. So again, if I enter a 1 as the input of this function, then that would mean 1 year, and 1 year would be 1/10 of a decade. So I have to divide t by 10, right? And then if I input a 1 here, it automatically becomes 1/10, and it would be as if I input 1/10 into this function. So now basically we can do a couple of experiments. For example, let's say you have 10 years, so you want to enter a 10 into this function. So this 10 goes over here and becomes 10 by 10, and the function gives me the output for 10 years in equation number 2. So 10 years in 2 gives me what sort of output? So it gives me a of year of 10 is equal to 315 times 1.06 raised to the power 10 divided by 10, which is equal to 1. Now 10 years in equation number 1 would give me a of decade of well, 10 years is nothing but 1 decade, so it becomes a of decade of 1 is equal to 315 times 1.06 raised to the first power. So you can see that you will get basically the same outputs for the same duration of time from both the different functions, either from function 1 or from function 2. So basically that means that this function is working for us now. Now we can simply enter years into this function, and then it will give us the right output. But now there is a problem, and the problem is that I want to know what happens now the function takes years as an input, but it doesn't basically tell me what happens every year. And the problem is that increases by a factor of, so the factor, as we can see now, as we will see right now. So let's say you have this function number 2 here. I'm talking about only this function number 2 right here. And let's say you have t in years, and then you have your a of year of t. So if your t is equal to 0 here, your output becomes 315, because 0 divided by 10 is 0, and then this whole number raised to the 0th power becomes 1, and then 1 multiplied by this becomes 315. If you increment your t to 1, just incrementing by 1, you get basically 315 times 1.06 raised to the power 1 divided by 10. So that is basically the 10th root of 1.06. If you increment your input by another 1 unit, you will get 315 times 1.06 raised to the power 2 by 10. So basically this way, there is no direct way to know each time what's happening to the output of the function every time you are incrementing the input of the function by 1. But for example, in this case, you could simply know that in this equation number 1, you could simply form a table here, and then this is number 1, basically, this whole table. So you have t here, a of decade of t would be equal to, then if you entered your t as 0, then you would get output 315. Make your t1 number 1, so make your t1, it becomes 315 times 1.06. Make your t2, you have 315 times 1.06 times 1.06. So every time that you're incrementing your input by 1, your output is multiplied by another factor of 1.06. So this way you know that basically every time you're incrementing your input, your output is being multiplied by another factor of 1.06, and that's basically the same factor that we are interested in here. But in this function, there is no way to know what's going on. So there is no definite or direct way to know what factor is being multiplied here. So I need to make some changes to equation number 2, which is 315 times 1.06 raised to the power t by 10. So equation number 2 is a of, I guess, year of t is equal to 315 times 1.06 raised to the power t by 10. Now I can, so if I want to have the same result here, then I would have to have the same type of function, which is basically like this, only having the variable as the index of this common ratio, right? So I need to do the same thing here. And here the problem is that the index contains a constant as well. So here I have 1.06 raised to the power